The area of triangle 2, it's a negative area because it's underneath this line. So it's 1/2 base times height, 1/2 times 6 feet. What is this height? Well, so remember, if this is 0 and it's going down 1,200 pounds per foot over a span of 6 feet, it's basically 6 times negative 1,200. And so that means this point right here is negative 7,200. I'm going to add that to my shear diagram because that's the shear right at this point. And then it's going to drop 8,000 right here. So that'll bring us to negative 15,200. I'm going to label that point as well. That's the shear down here. And then remember, it's going to keep dropping until it hits this number. And then it rises at the end by 18,800. So now we actually have all the major shear points on our shear diagram. And we can continue calculating these areas. So 1/2 times base of 6 feet times the height of negative 7,200. Negative 21,600. And triangle 3 has an area, well, it's not a triangle, it's actually a trapezoid, but it's just a combination of a rectangle and a triangle. The rectangle has a base of 3 and a height of negative 15,200. So 3 times negative 15,200 plus 1/2 base times height for the triangle. So base is 3 feet, height is the difference between these two. So it's going to be 18,800 minus 15,200. That's just negative 3,600. So basically 1/2 times 3 times negative 3,600. That gives us negative 51,000. And a good way to know if your areas are right is all the areas should add up to 0 because your moment diagram is going to start at 0 and end at 0. So if you do this plus this plus this, it should give you 0. We're right on. So these areas are correct. And I know my moment diagram is going to look good. So we'll do that next. Okay, so now I've gone ahead and written my 3 areas up here just for reference. I'm going to use that for my moment diagram. I've drawn my moment diagram line over to the side. Usually I put it under the shear diagram, but in this case I ran out of space. And I kind of marked some key distances because remember at 11 feet it intersects here, at 17 feet this part happens, and at 20 feet we get to the end. So I've marked out those values to help me draw. And the thing to remember about moment diagrams is that the slope represents the position on the shear diagram. So it starts off at a position of 13,200. That's the slope here, so it's very steep. But what's happening to that position? It's dropping and eventually it reaches 0. So at 11 feet, our slope keeps dropping until we have a slope of 0. That's kind of our peak right here. And then we have this negative moment. So I actually know that the area of triangle 1, 72,600, is that maximum peak. That's the amount the moment diagram goes up by. But then it's going to drop by 21,600. Notice that the slope goes from 0 to a negative slope, and the negative slope keeps getting steeper. So for the next 6 feet, basically the slope just kind of starts to get gradually steeper and more negative, right? More and more negative slope. That's what we see here. And it goes from 72,600, we have to subtract this amount. That gives us a value of 51,000 right here. So now that's where we are. And then what happens? Suddenly this position drops a lot, which means the slope does a quick drop. So we get very steep slope all of a sudden, and that's going to take us all the way home, and it's going to drop by 51,000. So we go down to 0. Now, you could get into the complexities of are my slopes correct and is the curve drawn right? It doesn't really matter because when we draw a moment diagram, we're looking for the maximum moment, which happens right here.